So hi everyone, welcome and thank you for tuning in. My name is Niv. I'm a solutions architect at Aporia. Aporia is a fully customizable monitoring platform for your machine learning models in production. And before I joined Aporia, I came from a background of software engineering and cybersecurity, specifically on embedded or edge devices, which is exactly what we're going to talk about today. So we'll talk about monitoring machine learning models specifically on edge devices. So running machine learning models on edge is a practice that has become extremely common in the last couple of years. We're seeing multiple industries moving and shifting in that direction. Automotive industry, medical industry. We're actually seeing home appliances devices running machine learning models on the devices themselves right now. So a lot of industries moving in that direction and many more. And this practice has become so popular that there are now technologies created specifically for that. We have companies like Halo, Qualcomm, NVIDIA, and many more manufacturing chips designed explicitly for running machine learning models on edge devices. And the reason it has become so popular is because it's an extremely powerful tool. It allows us to make real-time decisions based on predictions of machine learning models. And it allows us to do so because it spares us the time it takes for the overhead of having to send that data to the cloud, making the prediction on the cloud, and then waiting for the result from the cloud. So these are a couple of seconds that really make the difference between real-time decisions or not. And when we have the machine learning model running on the edge device, we're sparing this time. In addition to that, we're actually sparing costs as well, because we are sparing the data costs involved in sending the data to the cloud. So running machine learning models on edge is a very powerful tool. But as the old saying goes, with great power comes great responsibilities. And now that we have machine learning models involved in the biggest and most key decisions of our product, we want to make sure that they're working well. And for that, we'll need monitoring. So let's get to it. How do we monitor machine learning models on edge? Like any other system, what we need, first of all, is the data. So we need to send the data from the edge device to the cloud. So we'll have the edge device report log and report all the predictions that it's performing and send it to the cloud through some API gateway. And it will eventually reach some sort of storage, right? This can be an S3 file, a database, a data lake, whatever solution you want is okay. But the important thing is that the data is stored somewhere. And then we'll have our monitoring system. A monitoring system will take all of the predictions from the storage and then calculate metrics and aggregations that allow us to understand from these predictions whether our model is performing well or not, right? Let's say we want to see if we have a data drift. The monitoring system will calculate distributions and compare distributions, for example, the distribution in production to the distribution of the training data, or distribution on production data of last week versus this week's data. And we'll see if there's a big enough difference between the distributions to understand that there is a drift. If we want to see how a model is performing, we have performance metrics, like F1 score, precision rates, recall, etc. And again, our monitoring system will calculate those and probably save them to some local database, so it doesn't perform these calculations all the time. And then we'll have some sort of user interface, right, that just shows graphs and distributions and basically allow the data scientists to get visibility into all of these metrics that we're calculating to understand if the model is performing as expected and if we have any concerns. Either that, or we can just generate automatic alerts in case we're not meeting some business KPI. So that seems like we got it all sorted out, right? So what do we need the extra 5 minutes for? The problem is that sending data from edge devices is exactly what we wanted to avoid, right? Because when you're talking about edge devices, they do not have the same connectivity luxury that you have when you're running on the cloud. You could have connectivity issues, right? You could be running on metered networks, which means that every byte counts, literally. So if you're trying to send all of the data from all of your devices, all of the predictions, this could be a lot of data. And if every byte costs you money because you're on metered networks, then it could render your monitoring system not cost efficient. You could be roaming, right? For example, smart cars, right? They're driving, they're changing locations, they're roaming. And if you're driving up on the mountains, for example, then you may not have connectivity all the time. Actually, you probably do not have connectivity most of the time out there. So what do you do in these times? What do you do in these locations? Do you just not log the data from those locations? In addition to that, IoT devices may be running on networks that are low throughput by definition, right? We're seeing that a lot in the agriculture industry, for example. Devices using protocols like ZigBee, Z-Wave, or just have a network infrastructure that is built to be low throughput. They simply don't have enough bandwidth to send all of the data to the cloud. In addition to that, you can have huge data costs if you're trying to send all of the data from all of your devices to the cloud. Let's say you have 2 million units, right? You have some sort of product, you've sold 2 million units of it, and this product is making on average 1 prediction per minute, which is not a lot, right? It's a very reasonable amount. It's actually fairly low. Let's calculate how many predictions per day that is. So we have 2 million predictions per minute times 60 minutes an hour times 24 hours a day. That's over 2.8 billion predictions per day. That's a lot of data. And storing all of this data comes at a cost. Moreover, now our monitoring system here to the right has to analyze every day, has to calculate metrics based on 2.8 billion predictions. And processing all of this data, again, comes at a cost. So data costs, again, can render our system to be not cost efficient. In addition to that, we may have privacy concerns. You may be using features that you're not allowed to send to the cloud. For example, you may be using GPS location as one of the features, right? It's one of the inputs to your model. And your end user license agreement does not permit you to send GPS locations to the cloud. What do you do in that case? How do you still monitor? How do you make sure that your model is working properly? In addition to that, the last issue I want to bring up is monitoring granularity. When you're talking about edge devices, you can view it as one system, right? Let's say again, we have 2 million units. You can look at it as one single model that's simply running in a decentralized manner and simply running on multiple endpoints. But it's one system, so all of the metrics you're calculating, all of the aggregations you're calculating, it's for the system as a whole. That may be the case in some cases, but usually what we want is we want to monitor on a single device granularity. And why is that? It's because every device is completely different. It's being used by someone else. It's getting different data. It's being used in a completely different manner. And we want to make sure that each individual device is running properly. And your monitoring system may not be adapted for that case. And even if it is, let's say, again, we have 2 million units. Now, instead of calculating, for example, distribution for one system, it needs to calculate 2 million distributions. And again, that's a very high data processing cost. So what do? How do we get a monitoring system that's still cost efficient and allows us to monitor all the devices? What we'll do is do exactly the same thing that we did when we put the machine learning model on the edge device in the first place. We're going to offload responsibilities to the edge device. When we offload these calculations to the edge device, what we'll end up with with is a system that only sends metrics to the cloud. And that way we're sending much less data, because we can, for example, aggregate the data over an hour, over 24 hours, depends on the resolution you're looking for. And instead of having to send all of the predictions performed in 24 hours, we're just sending the average, the distribution, and, for example, the precision rate over 24 hours. And that way, we're sending much less data, so we're avoiding the high data storage costs. And we're also avoiding the connectivity issues, right? Because we can send it only on specific times in which we have connectivity. And in addition to that, we're getting the single device granularity as a bonus, because now in the prediction storage, instead of storing all of the predictions, you're storing each device's metrics, and all the monitoring system has to do is display it. So there are many more things I can go into in this architecture, and I can dive much deeper into, but unfortunately we don't have the time for that. Feel free to add me on LinkedIn or just email me. I'll be happy to explain how we can leverage the configuration and how we can play with it a bit to make sure that the monitoring system works for your individual use case and with your individual needs. So feel free to add me on LinkedIn or just email me. And I hope you found this talk interesting, and thank you for listening.